Okay. So we'll start it today class. They didn't announce. They told me class is at 6:30. That's why I started now. Okay. So okay, we'll start it. Good evening. Okay, no problem. Okay. Right. Last day we completed homework problems. Today we'll close this root locus. We'll start the frequency domain analysis. Next problem. What happened? Right. So draw the root locus. For g of s, h of s equal to k into e power minus s by s into s plus 1. This is called transportation delay system. E power minus 1 represents the delay. E power minus 1 represents the delay in the system. So transportation delay system. It is called transportation delay. Already I told in the starting classes what is a transportation delay system. Delay is there. That's all. Delay system means it. Sometime there will be a delay in the system, like g of t minus tau function. It will come in the event signals and system analysis. So now how to find the stability for this system? So how to find the stability? Exact stability not possible here. You have to go by approximate only. Why? Because we need to expand the exponential term. So k into e power minus s can be written as what? 1 minus s divided by s into s plus 1. Neglect higher order terms. Neglect higher order terms. Neglect higher order terms. You have to neglect the higher order terms. Okay. Now, here main one simple question, you answer it. What is the pole location? What is the zero location for 1 minus s? What is the location of 0? What is the location of 0 for 1 minus s? What is the location? Plus 1. Plus 1 or minus 1? It is plus 1, no doubt. Plus 1, s equal to 1, na? So 0 location is plus 1. For s minus 1, what is the location? For s minus 1, what is the location? Also plus 1 only. For both the things, plus 1 only. Not only this, if you take s plus 1, what is the location? Minus 1. Even if you take minus s minus 1 also, the location is what? Minus 1. Even if you take minus 1, minus s minus 1 also, the location is minus 1. That means we cannot differentiate the location for 1 minus s and s minus 1. Even we cannot differentiate between these two terms, s plus 1 minus s minus 1. But there exists a 180 degrees phase shift here. There exists a 180 degrees phase shift between these two as well as between these two. 180 degrees phase shift is there between these two. Minus 1 sign common, na? Here also minus 1 sign common, na? So 180 degrees phase shift is there. So that's why what they told. So as we are unable to differentiate the location of the 0 or even location of the pole, what they told, there should not be any negative sign to the s. In the transfer function, be remember to draw the root locus diagram. To draw the root locus diagram, RLD, root locus diagram. To draw the root locus diagram in the open loop transfer function, that means G of S, H of S. In the open loop transfer function, G of S, H of S, the S term should not be negative. The S term should not be negative. The S term should not be. S term should not be negative. At any cost, S should not be negative. S should not be negative. So at any cost, S should not be negative. Should not be negative. So that means what? S you have to take it common. Minus sign you have to take it common. So either it may be in the numerator, it may be in the denominator. Even for example, here 2 minus S is there. That minus sign should take common. So that means minus K into S minus 1 divided by S into S plus 1. To this you have to draw the root locus diagram. To this we have to draw the root locus diagram. To this we have to draw the root locus diagram. Listen carefully, all of you. Actually, what I am discussing in this, there is a chance of asking 1 or 2% only. Very less chance. Generally, 99% the questions on direct root locus, that also direct only it will be there. Because 2 marks bit they cannot ask very difficult question. Even very less chance to ask the draw what is the root locus diagram also. Even if you ask, apply 2-3 rules and then select the answer. So, but that 1-2% also should not miss it. That's why I'm discussing this. So this minus K into S minus 1 by S into S plus 1. Now here, what you have to draw, you have to identify. Either you have to draw the direct root locus or inverse root locus, and what is the direction of the root locus branch, you have to identify. So, what you have to draw, direct or inverse? What you have to draw? Direct or inverse? So listen. So here, what is the direction of the root locus branch? Pole to 0 or 0 to pole? What is the direction of root locus branch? Direction of root locus branch. Pole to 0 or 0 to pole? 0 to pole. Listen here. See, don't mug up anything. You should not mug up anything. You go by procedure, that's all. Because of minus K, don't take range of K from minus infinity to 0. Unless until mentioned in the question, never take range of K minus infinity to 0. So by default, this minus sign we got because of the system. It is nowhere related with K. And if write like this, K positive. If write like this, K negative. No. So it is nowhere related with what? This minus sign nowhere related with K. That minus sign we got because of the system, not because of the K. So that's why by default range of K is 0 to infinity. Unless until mentioned in the question, never take the negative value of K. By default, K is 0 to infinity. By default, K is 0 to infinity. That means what is the direction of the root locus? Direction of the root locus branch? Where K0 at open loop pole. K0 at open loop pole. K infinite at where? Open loop 0. K infinite at open loop 0. Open loop 0. So this is the direction. This is the direction. This is the direction of root locus branch. It is the direction of root locus branch. From open loop pole to, because here K is 0. Here K equal to infinity. Next. This is the first. Next, second one. What you have to draw? Either direct root locus or inverse root locus. For that, you have to verify the angle condition. For that, we have to verify the angle condition. So, angle condition. You have to verify angle condition. First write the characteristic equation. By default, negative feedback only. Never consider positive feedback. By default, negative feedback. By default, negative feedback. By default, negative feedback. So that means what is the characteristic equation? 1 plus g of s h of s equal to 0. 1 plus g of s h of s equal to 0. 1 plus g of s h of s equal to 0. Now substitute g of s h of s. If we substitute g of s h of s, what I will get? 1 minus k into s minus 1 by s into s plus 1 equal to 0. Equal to 0. Then come to the next page. Come to the next page. Now k into s minus 1 by s into s plus 1 equal to 1 plus j0. 1 plus j0. So now angle condition. Apply the angle condition. So bolo angle of k into s minus 1 by s into s plus 1 is equal to angle of 1 plus j0. So what is the angle of 1 plus j0? 0 degrees. Angle of 1 plus j0 is 0 degrees. That means what? We require to draw the what? Inverse root locus. 0 degrees means we require to draw inverse root locus. Inverse root locus you have to draw. So 0 degrees means inverse root locus, in which direction is what? From pole to 0. Don't think that inverse root locus means direction should be 0 to pole. Wrong. Direction decided by range of k, and what diagram you have to draw, that is decided by angle condition. So here we have to draw the inverse root locus in which the direction is from pole to 0. I told very clearly conversions from direct root locus to inverse root locus. Is remembered or not? I told it, conversion from direct root locus to inverse root locus. What is the conversion from direct root locus to inverse root locus? What is the conversion from direct root locus to inverse root locus? Come on. First, rule 3. Rule 3. So there is a term odd. There is a term odd. In rule 3, there is a term is odd. Replaced by even. In inverse root locus, the odd replaced by even. That means what is the statement tell? A point to lie on inverse root locus. A point to lie on inverse root locus. A point to lie on inverse root locus. The sum of the poles and zeros to the right hand side of that point. To the right hand side of that point should be even. To the right hand. Previously we counted odd, na? Now we have to count right to that point should be even. Right to that point should be even. Next, rule 4. What is the formula for angle of asymptotes? Tell. 2q plus 1 into 180 degrees divided by p minus z. Divided by p minus z. So whereas here, what is the angle of asymptote? Theta. 2q into 180 degrees divided by p minus z. 2q plus 1 replaced by 2q. I told already. In rule 8, I'll write instead of angle of departure and all that, pi at poles. What is the formula? Tell. 180 plus angle GH. 180 plus angle GH. Pi at zeros. 180 minus angle GH. 180 minus angle GH. 180 minus angle GH. Whereas here, pi at poles. What is the answer? 180 replaced by 0. 0 plus angle GH. So here, pi at zeros. Complex zeros. Zeros means. This is applied for complex, na? Complex poles, complex zeros. So what is the answer? 0 minus angle GH. These three only different from direct root locus to inverse root locus. Remain all are same. These three only different. So remain all are same. Remain all are same. Now we'll draw the inverse root locus, in which by taking the what direction from pole to 0. Now draw the inverse root locus. Come on, what is g of s h of s? G of s h of s equal to minus k into s minus 1 by s into s plus 1 minus k s minus 1 by s into s plus 1 s plus 1. Now come on, draw the diagram inverse root locus. Represent the poles and zeros in the S plane. Represent the poles and zeros in the S plane. Little bit chota will draw. Okay. Come on. One pole at origin. One pole at origin. Next, one pole at minus 1. Here k equal to 0. Here also k equal to 0. And 1 0 at where? 1 0 at plus 1. Plus 1 here k equal to infinity. K equal to infinity. Now identify the inverse root locus branch. Identify the inverse root locus branch. Where are the inverse root locus branches to identify? So is there here inverse root locus or not? Take a point, count right 0. 0 means take a point, count right 0. If you take a point here, count right 0. 0 means what? Even. So there exists the what? Inverse root locus. Next, here take a point, count right 1. 1 means odd. Odd means there is no inverse root locus. Take a point, count right 2. 2 means even. There exists the inverse root locus. Here exists inverse root locus. Here take a point, count 3. 3 means odd. So there is no inverse root locus. So like this, you have to identify inverse root locus branches. Inverse root locus branches you have to identify like this. Next, calculate the break point, number of asymptotes. So number of asymptotes equal to what? P minus Z. Same thing remain. So that means what? 1. Angle of asymptote, what is the formula? 2q into 180 here. 2q into 180 by P minus Z. So first value of q is what? 0. First value of q is 0. That means what is the answer you are getting? 0 degrees. That means at 0 degrees, there exists a 0. At 0 degrees, there exists a 0 where k equal to infinity. Next, centroid not required because angle of asymptote 1 means centroid not required. Centroid required when number of asymptotes more than or equal to 2. Next, break point you required. Find the break point. So how to find break point? Simply dk by ds. D by ds of break point, even no need to take sign common also. If the break, after finding break point, if it is lies on root locus, valid for direct root locus. If it lies on inverse root locus, valid for inverse root locus. That's all. So come on, what is the answer? Minus of s minus 1 by s square plus s. So now equal to 0. So d by ds of, I can write 1 minus s by s square plus s equal to 0. U dash means minus 1 into s square plus s plus minus kada, minus u 1 minus s. U dash v minus u into v dash. V dash means 2s plus 1 equal to 0. Now solve this. You solve this and find the roots. You'll get the break points is minus 0.414 comma 2.414 you will get. point minus 0.414, 2.414. Both are valid only. Here 2.2. Dekho, here break point 2.414. It is on inverse root locus, so valid for inverse root locus. Minus 0.414 also inverse root locus. It is valid. Minus 0.414 also it is valid. So both are valid. Both the breakpoints valid. It is not valid for direct root locus. It is valid for only inverse. Why? Because if we draw the direct root locus, what happened? Tell. If we observe the direct root locus branches, one pole here, 1 0 here. Here there exists the direct root locus. Here direct root locus. Here K0. So here K infinity. It is direct root locus. Here also K0. Here no direct root locus. Here exists the direct root locus. Even number of asymptotes find one, angle of asymptote become 180 degrees. Here K infinity. This will become the direct root locus diagram itself directly, because directly we are having a path from the what? Pole to zeros. So this is the direct root locus. But it is wrong. So let's see here, there is no break point here. So, but here these two breakpoints are valid for inverse root locus. These two breakpoints are valid for inverse root locus. So here one, here one. Now draw the diagram. As K increases, both the poles move opposite direction, then collide. After collide, it leaves the real axis, then turn toward the right. Turn toward the right and enter at the breakpoint. Turn toward the right, enter at the breakpoint. Enter at the breakpoint. Both the poles turn toward the right, enter at the breakpoint. Enter, both are turn right. Turn right, enter at the breakpoint. Enter at the breakpoint. Enter at the breakpoint. Then what happened? One pole moves toward the 1 0, another pole moves toward the another 0. That's all. This is the what? Inverse root locus in which the direction is what? It is a inverse root locus in which the direction is what? Pole to 0. In which the direction is pole to 0. So don't think that in direct inverse root locus means direction should be pole to 0. It is wrong. So direction completely decided by range of K value. Direction completely decided by range of K value. Be remember. Okay, na? So this is the inverse root locus in which K increased from 0 to infinity. And you can find here even range of K value here. K value you can find 0 to up to this. It is going to be stable. Everything we can find. Okay, na? And one more thing here. In case you are, for example, in the exam given negative value of K, not in a standard form, positive feedback, negative value of K, K minus infinity 0, something they given. You are unable to identify what diagram you have to draw. You are getting lot of confusion case. Then what you do? I told generally any question comes on inverse root locus. Very rare cases, 1 or 2 questions you may find from last 30-40 years questions if you refer also. So if you find like that questions, generally you will ask maximum second order only. Most of the case first order, worst case second order. Second order they will ask, maximum second order. So second order means we can use the other method also. What is that? By using characteristic equation, we can find the answer. Roots we can find in up to second order. Up to second order, we can find the roots. According to what is the definition of root locus diagram? It is simply closed loop poles path. Root locus diagram is nothing but simply closed loop poles path. Identify the closed loop poles path. That's all. Directly will get the answer. So for example, see, I'll take the characteristic equation, verification. For example, they given like this, minus K, positive feedback, negative feedback, something given. You are getting confused. Order maximum second order they will give. They don't give third, fourth, no doubt, 100% guarantee. They don't give. Simply use the characteristic equation and select the answer. That's all. No rules kuch bhi nahi. Just verification. Listen. Verification to select the answer. Verification. Just verification to select the answer. To select the answer. Verification just. What is the character? Don't take sign common kuch bhi nahi. As it is you take. ठीक है ना? So what is g of s, h of s? Don't take sign also common. So what is that? K into 1 minus s by s into s plus 1. Now characteristic equation. Characteristic equation. 1 plus g of s, h of s equal to 0. That means what? What is the characteristic equation? 1 plus k into 1 minus s by s into s plus 1 equal to 0. Then what is the characteristic equation? S square plus s plus k minus ks equal to 0. S square plus s plus k minus ks equal to 0. Now substitute the k value. Substitute the k value. What in the given range? Whatever the range given, that you take. K equal to 0, find the roots. So what is the characteristic equation? K0 means s square plus s is 0. You find the roots. S equal to 0 comma minus 1. Next, in case k is negative, substitute from minus infinity to 0. Minus infinity take minus 10, minus 5, minus 2, minus 1, 0 and find the roots like that. So k equal to 1. So what are the characteristic equation? Tell s square plus s plus 1 minus s equal to 0. ss. Then s equal to what? Plus or minus j1. Plus or minus j1. K equal to 2. What is the characteristic equation? Tell. Characteristic equation tell s square plus s plus 2 minus 2s equal to 0. That means what you are getting? S square minus s plus 2 equal to 0. S equal to what? Bolo. What is s? You find the roots. 0.5 plus or minus j. I think 1.3 will get. Like this, 4, 5 values of k you find and observe the root locus diagrams. For example, k0, 0 and minus 1. Check it. This is direct root locus, which is wrong. Still check it. K0. Where is the pole? 0 at minus 1. 0 and minus 1. 0 minus. Here also 0 and minus 1. Next, K1. Pole should be where? Plus or minus J1. If K1, is there pole anywhere on imaginary? K1 means pole should come imaginary. Here no pole comes to imaginary. That means this diagram is wrong. Direct root locus is wrong. Now here poles are coming to imaginary. If you want to find intersection point, no doubt here K1 and intersection point is here k equal to 1, intersection point plus or minus j1 plus or minus j1, no doubt. Still k increase. What happened? Roots comes to right. Still k increase, roots come to right. According to our range of k, still k more than 1, roots come to right. That only you got na see. K2, roots are coming right. 0.5 plus or minus j1.3. That means 0.5 plus or minus j1. Still increase, it come to right. Still increase, it come to right. Up to infinity, the roots lies in the what? Right of S plane. That means by finding the roots, verifying the 4 options, we can select the answer. We are not going to be draw any root locus diagram that is given in the 4 options. Just you have to select the correct answer. Anytime you are getting a doubt, so either direct or inverse or anything, so just we can write characteristic equation. We can find the roots for some values of k and then directly we can select the answer without using any rules. Okay, na? So this is verification to select the answer. But here don't modify anything. No need to take sign common, kuch bhi nahi. So directly you get the answer. Okay, na? And one more thing, to get the confidence, I will take 4 problems. I'll take the 4 problems and in that 1 problem I'll solve. Just I want you should become perfect in identification of what diagram you have to draw, either direct root locus or inverse root locus. So you should perfect in identification of either drawing direct or inverse root locus. For that, I'll take 4 examples. Listen, I'll take 4 problems. Among that, one problem I'll solve. Whatever the problem you want, I will solve it. Okay. Just this is for I'm solving. One is for how to do verification. The second one is to identify what diagram you have to draw, either direct root locus or inverse root locus. Okay. First one, R of S plus K by S C of S negative. First case is K take 0 to infinity. Second case you take K minus infinity to 0. Second problem. Plus I'll take minus K by S C of S minus K 0 to infinity K minus infinity to 0. Third case, R of S plus K by S. Positive feedback. Again, 2 cases as it is. 2 cases as it is. Fourth problem, R of S summing point minus K by S C of S plus K. Same thing, 0 to infinity minus infinity to 0. So now tell which problem you want. Which problem you want? 1 or 2 or 3 or 4 or one problem I'll solve. Same steps you follow, you'll get the answer. Just same steps, whatever the steps I'll tell. So all are asking fourth one. Okay, I'll solve fourth one. Right, okay, right. I'll solve. Fourth one I'll solve. Listen. Same steps follow, 100% will get the answer for all the 3. So fourth one, first case. Fourth one, first case. So diagram remember na? Okay, no problem. What is the range of K first? First range of K. K is 0 to infinity. First case. That means what is the direction tell? From pole to 0. Direction is pole to 0. Direction is pole. First always direction you identify. First step you identify the direction. 1 minute. First step you identify the direction. Pole to 0. Identify the direction. Next, second step, listen. Second step, identify the K sign. K positive or negative you identify. K is positive. K is positive. K range, K sign you identify. Either it's positive or negative. Next, this is the first one. Second thing, given G of S. What is given G of S? You write. What is given G of S? Tell. Minus K by S. Given G of S is minus K by S. Minus K by S. Resultant G of S. Resultant means you have to resultant G of S. Resultant G of S means it is the sign of K, sign of the system. Why? Because what diagram you have to draw, that depends on three parameters. Either you have to draw direct root locus or inverse root locus. That depends on three parameters. One is system, range of K, feedback. All the three we have to include. All the three I have to. That's why first K I consider, sign of the system I consider. First I will product these two. So this sign positive as it is. So positive, and system as it is. System, this system as it is. That is minus K by S. Minus K by S. So now what is the product? Plus and minus what? Tell. And one more thing, resultant G of S means you will get the confused. That's why I'll write GR of S. Resultant G of S I consider as GR of S. Resultant G of S I will write GR of S. That equal to sign of the feedback, that is plus sign of the K, that is plus. Next, sign of the system. Sign of the system. Sign of the system means that is minus K by S. Both you product it. Both you product what is GR of S? Tell. GR of S. I'll write here itself. The space. Okay. What is GR of S? Tell. Minus K by S. Because plus into minus becomes the what? Minus. So minus K by S. Now feedback. Which feedback given? Given positive feedback. Given positive feedback. Positive feedback. That means what is the characteristic equation? 1 minus G of S. We have to write GR of S because resultant you have to consider. Whatever the feedback is there, that sign only you have to put, but in place of G of S, you write GR of S. 1 minus GR of S equal to 0. For positive feedback characteristic equation. Now what is the characteristic equation? 1 minus K by S equal to 0. 1 minus K by S equal to 0. Now tell angle condition you have to check. This can be written as 1 minus K by S na substituted. So what I can write? Tell 1 plus K by S equal to 0. Now angle condition. Below angle of K by S equal to how much you find? Angle of system you have to find. Angle of K by S equal to what? Angle of minus 1 plus J0. So if it goes one other side, it become minus 1. Na? If it goes one other side, minus 1. So that means how much? Tell plus or minus 180 degrees. So that means you have to draw the what? Direct root locus. We have to draw the direct root locus in which the direction is equal to 0. You have to draw the direct root locus in which the direction is equal to 0. Come on, draw the direct root locus. To draw the direct root locus. We'll do verification also. So here K equal to 0. Here there exists a direct root locus. Here there exists a direct root locus. Number of asymptotes 1. Angle of asymptote 180. Direct root locus na 2q plus 1 into 180 by p minus z is 1 means 180 degrees. That means here at 180 degrees, K equal to infinity, at minus infinity there exists a 0. Then what happens? As K increases, the pole moves toward the left, it occupies the zeros. The pole moves toward the left, it occupies the zeros. So as K increases, the pole moves toward the left and occupies the zeros. That's all. So this is the what? Direct root locus. So what is this? Open loop pole at K equal to 0. Open loop pole, even that equal to what? Closed loop pole. Even this is what? Open loop 0. That is nothing but closed loop pole, because k equal to infinity. Open loop pole equal to closed loop. Open loop k equal to 0. Open loop pole equal to closed loop pole. K equal to infinity. Open loop 0 equal to closed loop pole. So this is the answer. If you have any doubt about this, go for verification. If you have any doubt, go for verification. When you do the verification, no modification. Don't do any modifications. Verification means no modifications. Don't do any modifications. Verification, no modification. So now take characteristic equation. What is the characteristic equation? As it is, you take 1 minus g of s equal to 0, because positive feedback. Substitute g of s as it is. 1 minus, what is g of s? Minus k by s equal to 0. Now what is the characteristic equation? S plus k equal to 0. Now what are the closed loop poles? Closed loop poles, s equal to what? Minus k. S equal to minus k. Closed loop poles, s equal to minus k. So now k, what is the range of k? K should be increased from 0 to infinity. K should be increased from 0 to infinity. K should be increased from 0 to infinity. Now come on, K0 substitute. Where is the pole? Come on, K0 substitute. K0 means pole at origin. Substitute here. K0, pole at origin. Next K1, K equal to 1. Substitute here. K equal to 1 means S equal to minus 1. K equal to 1, S equal to minus 1. K equal to 10. S equal to what? Minus 10. K equal to infinity. S equal to what? Minus infinity. That means this is the what? Root locus diagram. This is a root locus diagram. Both are same or different? Tell. Both are same or different? Both are same. So this is a what? Closed loop pole. 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 This is a what? Closed loop pole path. So like this we can do the verification. Same steps you follow, you'll get the answer for all the three. Case 2 also I'll solve. Okay, so that remain 3 problems you can solve by yourself. Okay, na? Case 2, can you try? Right. Next. Case 2. What is the case 2? Fourth one, case 2. What is the range of k here? K range is what? Minus infinity to 0. Minus infinity to 0. That means what is the direction? Tell. 0 to pole. Range of k is minus infinity to 0. That means direction is what? 0 to pole. 0 to pole, because at open loop 0, k minus infinity. At open loop pole, k equal to 0. So direction is 0 to pole here. Direction is 0 to pole. Direction is 0 to pole. Now given k, k negative or positive? K negative or positive? K is negative. 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 Next. Okay, k is negative. Next one. Given g of s. Given g of s. What is g of s? Tell. Minus k by s. Given g of s minus k by s. Resultant g of s. Resultant g of s. Resultant g of s. So that is gr of s equal to minus the k sign. What is the sign of k? Minus. So minus. What is the sign of g of s? Minus. So minus k by s. So now tell what is gr of s? Gr of s become what? Plus k by s. Plus k by s. Now characteristic equation. Given positive feedback. Given positive feedback. So characteristic equation is 1 minus gr of s equal to 0. Bolo, what is gr of s? 1 minus k by s equal to 0. So then what happened? Characteristic equation is s minus k equal to 0. Sorry, angle condition. Na? Check the angle condition. So angle condition. So what is angle condition? Tell. Angle of k by s equal to 1 plus j0. Angle of k by s equal to angle of 1 plus j0. That equal to what? 0 degrees. So angle of k by s, angle of 1 plus j0, that equal to 0 degrees. That equal to 0 degrees. That means you need to draw the inverse root locus. You need to draw the inverse root locus. So draw the inverse root locus, in which the direction is what? 0 to pole. In which the direction is 0 to pole. Come on, draw it. Draw inverse root locus. Draw inverse root locus. One pole at origin. K equal to 0. S equal to 0. Here there exists the what? Inverse root locus. Here there exists the inverse root locus. Inverse root locus. Number of asymptotes 1. Angle of asymptote becomes 0 degrees. 2q into 180 degrees, na? So it will become 0 degrees. So 0 degrees. Where k equal to what? Minus infinity. Here k equal to 0. Now draw the diagram. As k increases, the direction starts from 0. So direction starts from open loop 0. It moves towards the pole. It moves towards the pole. This is the direction. It moves towards the pole. This is the direction. So this is the direction of what? Root locus diagram. This is the inverse root locus. And the direction is what? 0 to pole. Direction is 0 to pole. If you have any doubt, do the verification. If you have any doubt, do the verification. Verification. Verification means don't do any modification. No modification. As it is, you substitute. Given characteristic equation, given g of s. As it is, you substitute. So characteristic equation. So 1 minus g of s equal to 0. 1 minus g of s equal to 0. Now substitute g of s. What is g of s? 1 minus k by s equal to 0. Now write what is the characteristic equation? S plus k equal to 0. S equal to what? Minus k. What is the range of k? Tell. K should be increased from minus infinity to 0. K should be increased from minus infinity to 0. Minus infinity to 0. Now tell k minus infinity. Where is the pole location? Come on, this is closed loop pole. K minus infinity. Now draw the diagram. Right. K minus infinity. Minus become plus. That means plus infinity. K equal to minus infinity. Then S will become plus infinity. K minus 100. K equal to minus 100. S equal to what? Plus 100. K equal to minus 10. A equal to minus 10. S equal to what? Plus 10. K equal to 0. S equal to what? 0. So this is the diagram. So this is the diagram. Complete diagram like this. So this is the direction. Direction of inverse root locus. This is the direction. So both are same or different. This is a closed loop pole. This is also closed loop pole. This is also open loop pole, closed loop pole. This is also closed loop pole. This is a closed loop pole, na? This is also closed loop pole. Why? Because at k equal to 0, open loop pole equal to closed loop pole. So like this, you have to do the verification. First and second order, if you are unable to draw a root locus diagram, getting any confused, go for verification. Okay, na? No rules are required. but better prepare the rules because 70% of the questions only based on rules. So that's why you should be perfect in rules. With this root locus completed, one small topic is there, root contour. It is very, very important. After that, we'll start the frequency domain analysis. Root contour. It is very, very important. Actually, root contour not in syllabus, but they are asking many questions on this topic especially. Not they'll ask draw the root contour. They'll ask root locus diagram only. But they are using the concept of root contour in the question. They are using a concept of root contour. They are asking RLD. That's why this chapter very important. Listen. Whenever, what is the root contour first of all? Whenever transfer function or characteristic equation consists, whenever transfer function or characteristic equation consists multiple unknown parameters, multiple unknown parameters, whenever transfer function or characteristic equation consists multiple unknown parameters, then by varying all the parameters, by varying all the parameters, then by varying all the parameters from 0 to infinity, and drawing a root locus diagram, is called root contour. Whenever transfer function or characteristic equation consists multiple unknown parameters, then by varying all the parameters from 0 to infinity, drawing a root locus diagram is called root contour. Like for example, listen. For example, I'll take g of s x of s equal to g of s x of s, g of s h of s equal to, for example, I'll take k divided by s into s plus a into s plus 3, something like this. So here how many parameters are there? 2 parameters. One is k, one is a. Both you have to vary from 0 to infinity and drawing the RLD called root contour. Or even if you take a characteristic equation, for example, characteristic equation, they'll give like this: s cube plus as square plus 3s plus k equal, like this they'll give. Then they will ask it. So root locus diagram they'll ask. Then what you have to do? Here also, you have to vary all the parameters from 0 to infinity, drawing the RLD called the what? Root contour. But here, they don't ask root contour. We don't want root contour also. Just what you want it, adjusting the transfer function or characteristic equation into standard form. You have to adjust the transfer function or characteristic equation into standard form. In case you mentioned A as a system gain, this is not a GH for A as a system gain. Why? Because to draw the root locus diagram, the system gain term must be in the numerator. The system gain K. The system gain parameter must be in the numerator. The system gain parameter the system gain parameter must be in the numerator. Must be in the numerator. Like G of S, H of S equal to system gain. Whatever the parameter mentioned, that should be there in the numerator. System gain into zeros by poles. System gain into zeros by poles. G of S, H of S equal to system gain into zeros by poles. Zeros by poles. This is the word G of S, H of S. So system gain must be in the numerator. For example, once they ask a question like, even system gain should not be in the both the places. It should be only one place. Once they ask a question like this, for example, they ask like this. They given a problem like this. So G of S, H of S equal to K by S square plus S, K plus 2, for example. They given like this. They'll give like this. They'll ask the angle of asymptotes are. Centroid is. Like the root locus diagram is. Like this they'll ask. What are the angle of asymptotes? Tell? What are the angle of asymptotes? 90 to 70. But unless until adjusted standard form, we cannot identify. Don't write directly. It is not in standard form. 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 So that means you cannot add. Why? Because system gain only in the numerator. It is there in the denominator also. Then what you have to do? First you have to write characteristic equation. Characteristic equation. 1 plus G of S, H of S equal to 0. 1 plus G of S, H of S equal to 0. So now tell what is the characteristic equation. So if you take simply numerator K, add in the denominator, you will get it. So that is S square plus S into K plus 2 just plus K. You find 1 plus GH, you will get this only equal to 0. Then expand this. Expand and take K term separate. So S square plus 2S plus 2 is one term. These are terms other than K. Next take K terms. Here KS is there. Here K is there. K take it term. So S plus 1 equal to 0. So this is the character. Now you have to write G of S, H of S. While writing G of S, H of S, the K must be K and its product term must be in the numerator. Remain all are in the denominators. All are in the denominator. System gain its product terms must be in the numerator. Remain all are in the denominator. So that means what is G of S, H of S? Tell. G of S, H of S. This is 1 plus GH na. So for example, 1 plus GH is this. I'll divide with S square plus 2S plus 2. This equation. What I will get earlier? 1 plus K into S plus 1 by S square plus 2S plus 2 equal to 0. Now compare with 1 plus GH. Tell. What is GH? Tell. Compare with 1 plus GH equal to 0. What is GH? K into S plus 1 by S square plus 2S plus 2. Now GH equal to G of S, H of S equal to K into S plus 1 divided by S square plus 2S plus 2. S square plus 2S plus 2. That's all. Now tell number of asymptotes are what? 1. Angle of asymptotes are what? Angle of asymptote only 180 degrees. So everything will change. So after adjusting standard form only, you should draw the root locus diagram. So be careful. Okay, na? Okay. So you have to adjust like this into standard form. Simply system gain. You write up to this. After writing system gain, its product terms take in the numerator. Remain all the terms you write in the denominator. After writing characteristic equation, what is the characteristic equation you written? Tell s square plus 2s plus 2 plus k into s plus 1 equal to 0. To get g of s, h of s, to get g of s, h of s from characteristic equation, to get g of s, h of s from characteristic equation, write to get g of s, h of s from characteristic equation, k and its product terms write in the numerator, remain all the terms k and its product terms in the numerator, its product terms in the numerator, k and its product terms are in the numerator and remain all the terms in the denominator. Remain all the terms in the denominator. Remain all the terms in the denominator. That means simply I can write g of s, h of s equal to what I can write? K into s plus 1 by s square plus 2s plus 2. Then this is standard form to draw the RLD. Standard form to draw RLD. It is a standard form to draw RLD. That's all. Okay, na? Next, one question we'll draw on the root contour on this topic. Then we'll start the frequency domain. Okay. Right. Right. Problem. Draw the root locus diagram. Draw the root locus diagram to the given characteristic equation. To the given characteristic equation. To the given characteristic equation by considering first one, k as a system gain. K as a system gain. Second one, A as a system gain. A as a system gain. So now come on. What is the characteristic equation? S square plus AS plus K equal to 0. Come on, do it. So come on, draw it. Characteristic equation is S square AS plus K equal to 0. Now case 1. So here 2 parameters mean 2 cases. N parameters means N cases. So K is there, A is there. So 2 cases you have to draw. Case 2. So here what happened? K as a system gain. System parameter gain both are same. K K as a system gain. A 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 as a system gain. ठीक है ना? Next, come on, get the answer. K as a system gain means what is G of S, H of S? Tell. K as a system gain means what is G of S, H of S? K should write in the numerator. Remain all are in the denominator. S square plus AS. S square plus AS. Now this can be written as what? K by S into S plus A. Now draw the diagram. Number of asymptotes, how many? 2. Angle of asymptotes, tell. 180 by P minus Z. P minus Z is what? 2. 180 by P minus Z. P minus Z is 2. 180 by 2 means 90. And multiply with odd number means 270. Centroid, sorry. Here we have to treat A as a constant. We forget to write. K as a system gain and consider A as a, everything correct only. Here we have to write A is constant. A is constant. A is constant. A is constant. Constant means it may be 1, it may be 2, it may be 10, it may be 1000 or any value. A is any value. Now centroid you find. What is the centroid? Sum of real part of pole minus A. No zeros, divided by 2. What is the centroid? Tell. Minus A by 2. Now draw the RLD. Draw the RLD. This is one pole, pole at origin. Here K equal to 0. This is another pole, minus A. K equal to 0. Here there exists the root locus branch. Here there exists the root locus branch. So centroid minus A by 2. Even break point also will get minus A by 2. Number of asymptotes 2. One is 90. Along 90 there exists 1 0. Along 90 there exists 1 0. Along 90. Where K equal to infinity. Along 270 there exists 1 0. Along 270 there exists 1 0. Where K equal to infinity. Now increase the K value. Increase the K. Come on, as K increases, both the poles move in opposite direction. Both will collide. Both will collide. Then it leaves the break point. It leaves the break point. Then one pole moves along the what? Along the 90 occupies the 0. Another pole moves along the what? 270 occupies the what? 0. So that's all. This is the what? Root locus diagram. In case mentioned A as a system gain, so that means K is constant. Here K is constant. You have to take any constant. So A as a system gain. That means what is G of S, H of S? Tell. G of S, H of S equal to AS by S square plus K. This concept very important because sometimes in the exam, many times asked characteristic equation they are giving. Sometimes they are giving GH not in a standard form. You should know how to adjust into standard form. Now come on, number of asymptotes 1. Angle of asymptote 180. Centroid not required. So now draw the diagram. This question already I given homework actually. Ks by S square plus 4. Same thing. Come on. What happened here? 1 0 at origin. S equal to 0. And poles are what? Plus J root K is a pole. K constant here. Minus J root K is constant. What is A here? 0. What is A here? Infinity. Here what is A? At poles A 0 na? Here not K system gain. A is a system gain. So you have to consider A at poles is 0. A at 0 is infinity. Here there exists a root locus branch. Number of asymptotes 1. Angle of asymptote 180. A equal to infinity. at minus infinity. Now here breakpoint you find. How to find breakpoint here? How to find breakpoint? Breakpoint how to find? Breakpoint here dA by ds equal to 0. Breakpoint here dA by ds equal to 0. dA by ds equal to 0 here. That means what? d by ds of s by s square plus k you have to consider. Make equal to 0. S square plus k equal to 0. You find breakpoint, you will get plus or minus root k, you will get minus root k is valid breakpoint. Minus root k is valid breakpoint. So this is minus root k. It is a valid breakpoint. So as the A increases, these poles depart with plus or minus 180 angle of departure if you find. Enter at root k. Enter at plus or minus root k. Enter at plus or minus root k. It will depart with plus or minus 180. This is also depart with 180. Both are enter at breakpoint. Then one pole moves towards 10. One pole moves towards 10. Another pole moves towards the what? Another 0. Occupies 0 when A equal to infinity. So this is the what? RLD. When A increases from 0 to infinity. As the system gain parameter changes, the shape of the root locus diagram it changes. System gain parameter changes, shape of the root locus diagram is changes. See here K system gain, here A system gain. What happened? Shape of the diagram is going to be changed. That's all. With this RLD end. Okay, any doubt? With this root locus diagram completed. Check the angle condition. What is there, man? Default feedback is what? Negative feedback. Default ke positive. Default by default direct root locus. By default you have to draw direct root locus. That's all. Nothing mentioned me direct root locus only. You take this is GH K by S into S plus A. What is there to checking? K by a small things also asking. S square plus A 0. What is the angle condition? K by S square plus A equal to what? Minus 1. What is the angle? Plus or minus 180. What you will draw? Direct root locus. For small things. Already written GH. Check the angle condition to that GH. Default feedback, negative feedback. Verification also we can do. That also you are unable to do. Take A is some value. For example, 2. What is the characteristic equation? S square plus 2S plus K. Now K0. What is the pole? K0. This is minus 2. K0 pole location tell. S is 0, comma minus 2. Is there or not? Next K1. Come on, find S square plus 2S plus 1. S plus 1 whole square. What is the pole? Minus 1. Is there or not? Still increase. Complex conjugate. Small things. They were not applying. Before asking the doubt, you should put the pen on paper and then you have to check either I am able to get or not. Okay. Next. Any more? No more. Read. Root locus, you have to read more. Unless until if you read more, you don't get the answers. Root locus is little bit difficult. In a control system, little bit difficult topic means root locus only. Remain all are very easy. Okay? No more doubts, Any doubt? No more. You can write the hand also. Right. Next. Susmita, tell.
సార్ క్వశ్చన్స్ లో డైరెక్ట్ గా ఆర్ఎల్డి ఇచ్చి ట్రాన్స్ఫర్ ఫంక్షన్ ఫైండ్ చేయాలంటే ఈచ్ వన్ చూసుకుంటా వెళ్ళాలా సార్?
That's all. First you write the transfer function. For example, they
Okay.
give root log, they'll give the location, na?
Yes sir.
A location means you can identify pole or zero, na?
Yes sir.
If they don't give pole, you observe the direction. For example, given like this, they'll put like this. Or
Okay,
they'll write k equal to 0 means that will be a pole.
Pole sir.
Then we can write now easily. For example, this is 0, this
Yes
is
sir.
-4. Like this, they given diagram. What is the transfer function tell? K by s into s plus 4.
4, yes sir.
Yes or no?
Yes sir.
For example, if you give like this, both are opposite direction, 0, -2 here, for example, -4. Like this given. What is the transfer function tell?
S plus
Here
4
k
by s
infinity,
into
here
s
k
plus 2.
0, here k 0. What I will get? K into
S plus 4 by s into
s plus 4 by s into s plus 2.
S plus 2.
You can write na?
Okay sir.
Okay. Any more? Right. Next, put the heading. 1 minute. Root locus, you have to work more, Aya. You concentrate. It is not difficult. If you read it, everything become easy only. You have to spend the time. You spend the time, everything becomes easy. If you don't spend the time, everything become difficult only. Difficult and easy, it completely depends on your hard work. That's all. Your how much time, not hard work also. How much time you are spending. No breaks are today. No break. Already started at 6:30, na? You want break? Some people are asking break, sir, break, sir. Want break? 5 minutes, only 5 minutes. Okay, take 5 minutes break. I will be here only. Exactly 5 minutes only. Only 5 minutes, I will be here only. Just 5 minutes only. Akans, what is your doubt? 5 minutes, you can ask doubts.
Hello.
Tell.
Sir, can you please once explain angle condition in page 6F? Means simply how you are writing 1 plus 0G.
What you want? What is the angle of 1?
Sir, 0 degree.
That's all. It is a positive real axis.
So how you are writing K by S is equal to angle
From
of
this,
K?
1 minus K by S equal to 0. K by S is a system. This one is outside, other side you have to take.
Okay, sir. So and now also when you were writing angle K by S square plus 1.
That's all.
So then there how did you do? So when some denominator is there, K by S square
anything, what GH is whatever you want to take it. Characteristic equation is what? 1 plus GH default. So that means what happened? 1 plus that something equal to 0. Something equal to what is the angle? -1 na?
Yes sir.
In case here minus sign is there, it will become +1. No?
Okay. So means here 180, how 180 will come means I'm having
angle
problem.
of -1, what is the answer?
What sir?
Angle of -1.
0 degree itself.
-1 also 0.
So angle of -1. Okay, -180. 180. Yes, sir, yes.
Starting positive real axis 0 degrees, negative
yes,
angle,
180,
negative real axis 180.
Okay, yes, got it. Thank you, sir.
Any more? Venkatesh? Venkatesh, tell.
Sir.
Tell.
Sir, K equal to positive. K equal to negative this one, sir.
Where? They given in the question. They given in the question. Question, you read it here. If you give in the question, you have to consider what is the k here given. Next, second case.
Minus infinity.
That's all. If you don't give, you have to take always 0 to infinity only.
If it is
Okay.
minus infinity to 0, it is k value is minus, sir.
K value negative.
Okay, sir.
Right. Put the heading. Right. Next. Frequency domain analysis. Frequency domain analysis. First, frequency response. What is the frequency response? What is the frequency response? Whenever they'll give the sinusoidal input to the system, the output also sines. What first definition of frequency response you tell? Observing the magnitude and phase. Observing the magnitude and phase for different frequencies. Observing magnitude and phase for different frequencies. Observing magnitude and phase for different frequencies, different input frequencies, and drawing magnitude plot with frequency, drawing the plot magnitude versus frequency, drawing magnitude versus frequency plot, drawing magnitude versus frequency plot, and phase versus frequency plot. Versus frequency plot. Is called frequency response. Observing the magnitude and phase for different frequencies and drawing a magnitude plot. Magnitude plot means magnitude versus frequency plot, and phase versus frequency plot is called the frequency response. See, one more thing here, be remember, for any LTI system, for any LTI system, if input is sinusoidal, the output also sinusoidal. The output also sinusoidal, but difference is magnitude and phase. Input sinusoidal, output also sinusoidal, but the difference is what? Magnitude and phase. So if we consider standard form of the input is R of t equal to A sine omega t plus or minus theta. If you write the output for this, the magnitude should be multiplied. Why? Because input output same sine wave only. Difference is what? Magnitude. So magnitude should be multiplied. And phase should be added. And phase should be added. Be remember, the change in magnitude and phase should be added. Automatically you will get the answer. In case if we take r of t in cos, a cos omega t plus or minus theta. If you write the output, same thing, magnitude should be multiplied and phase should be added. Phase should be added. Always magnitude multiplied and phase should be added. So this is the what? Frequency response. In the frequency response, input sinusoidal, output also sinusoidal. There is a difference in magnitude and phase. As the input frequency changes, output magnitude and phase is changes. So that magnitude multiplied, phase is added, then directly will get the output. Note down one problem. Note down one simple problem. Right. The closed loop transfer function of a unity feedback system is C of S by R of S equal to 1 by S plus 1. 1 by S plus 1. For the input, R of t equal to sin t, the steady state output is R sinusoidal response is come on, get the answer. Just to find the magnitude and phase, you'll get the answer. So first compare this input R of t sin t, R of t equal to sin t, compare with the standard form of input. Then find omega value. Sin of omega t, what is omega 1? Omega 1, S equal to j omega, S equal to j1. Then C of j1 by R of j1 is equal to 1 by j1 plus 1. Substitute in the S plus 1. So 1 by j1 plus 1. Then get the magnitude. 1 by root of a square plus b square, 1 plus 1. 1 by root 2. Get the phase angle. Angle pi equal to angle of 1 by angle of j1 plus 1. Here 1 means 1 plus j0 na. Tan inverse of imaginary by real. 0 by 1 means 0 degrees. Tan inverse of imaginary by real. 1 by 1. Tan inverse of 1 by 1 means 45 degrees. So that means minus 45 degrees. Then write the C of t. Magnitude should be multiplied. Here 1 is there. So 1 into 1 by root 2. Sin of t minus 45 degrees. This is the answer. One more problem is solved. But this method valid for only stable systems. You should not do for unstable systems. Unstable, they don't ask first. No need to worry. So this method valid for only stable systems. Next problem. Repeat the above problem. Repeat the above problem. G of S, H of S equal to S plus 1 by S plus 2. Sorry, C of S bar of S. R of T is 10 cos 2t plus 45. Come on, do it. Come on, Guruji, come on. Right. Come on, get the answer. Omega equal to 2. S equal to J omega. S equal to J2. C of J omega and omega S2 na. So S equal to J omega na. So C of J2 by R of J2. That equal to J2 plus 1 by J2 plus 2. Now write the magnitude. Root of 4 plus 1 by 4 plus 4. Root of 5 by 8. Root 5 by 8. Phase angle. Angle of J2 plus 1 by angle of J2 plus 2. Tan inverse 2 minus tan inverse 2 by 2. Here 2 by 1 na. Tan inverse 2 is how much? 63.43 I think. 63.43 I think. Tan inverse 1 na 45 degrees. That is 18.43 degrees I think. Then write the C of T. So 10 into root of 5 by 8 cos of 2t plus 45 degrees plus 18.43. That equal to 8 cos of 2t plus 63.43. Next, one more problem. Write this, solve this problem. Solve this problem. A system y of s by x of s equal to s by s plus p as an output as an output y of t equal to 1 cos 2t minus pi by 3 to an input r of t equal to p sine 2t minus pi by 2. P sine p cos kada cos. P cos 2t minus pi by 2. Then the system parameter p is. Then the system parameter p is. Come on, do it. Come on, get the answer. Solve it. Abdul, what is the doubt? Remain student, solve it.
సార్ మనం ఎందుకు లీనియర్ టైం ఇన్వేరియంట్ సిస్టమ్స్ తీసుకుంటాం? లీనియర్ టైం
Non-linear syllabus లేదు కదా. It is not in syllabus, non-linear.
లీనియర్ నేను అడుగుతాను సార్. లీనియర్ టైం వేరియంట్.
That only I am telling. Or else we are having in the syllabus LTI systems only.
ఓకే
Otherwise, you have to go for non-linear control systems.
ఓకే ఓకే
Come on, get the answers. So here given input and output, they are asking P. You go by procedure simply. Omega given, write the magnitude, write the phase, and then write the output. This is x of t. Take this x of t. First write the output, that output compare with given output, then you will get the answer. So come on, omega equal to 2. S equal to j omega. S equal to j2. Y of j2 by x of j2 equal to j2 by j2 plus p. j2 by j2 plus p. Now write the magnitude. What is the magnitude you are getting? 2 by root of 4 plus p square. What is the phase angle? Pi. Angle of j2 by angle of j2 plus p equal to pi by 2 minus, or we can write 90 also. So you'll write in terms of pi. Pi by 2 means 90 minus tan inverse of 2 by p. Now write the output. Y of t you write. What is y of t? P into magnitude multiplied. 2 by root of 4 plus p square. Cos of 2t minus pi by 2 plus pi by 2 minus tan inverse of 2 by p. Then what happened? This pi by 2 get the cancel. Then what is left? Y of t. That equal to 2p by root of 4 plus p square cos of 2t minus tan inverse of 2 by p. Now compare with input. Compare with given output. Given output. What is given output? Tell. Y of t given is 1 cos 2t minus pi by 3. Compare these two. Compare. First compare magnitude. Compare magnitude. Compare magnitude. Compare magnitude. Come on, what is the magnitude? Tell. 2p by root of 4 plus p square equal to how much? 1. 2p by root of 4 plus p square equal to 1. 2p. Cross product it. So cross product and then solve. 4p square equal to 4 plus p square. Then 3p square equal to 4. P equal to 2 by root 3. That's all. This is the answer. Or even compare face. You'll get the same answer. Compare face. Compare face. Bolo, what is the face? 2t minus tan inverse of 2t minus tan inverse of 2 by p minus equal to 2t minus equal to 2t minus pi by 3. Pi by 3. Now 2t cancel. Minus minus become plus. Tan inverse of 2 by p must be equal to pi by 3. So 2 by p equal to pi by 3 means 60 degrees. So tan 60. That equal to root 3. So p equal to what? 2 by p equal to 2 by root 3. That's all. So like this you have to solve it. Next, frequency domain specifications. Next, frequency domain specifications. Frequency domain specifications. What are the frequency domain specifications? Anybody? What are the frequency domain specifications? Resonant peak, resonant frequency, bandwidth, gain margin, phase margins, even free, all are frequency domain specifications only. So now, right, consider the RLC circuit. Consider the RLC circuit. Consider RLC circuit as shown in figure. As shown in figure. So draw it. Come on, find the transfer function. Find the transfer function. Laplace of capacitor 1 by SC. V naught of VI of S. Already we find the transfer function to this, either remembered or not. What is the transfer function? Tell. V naught of S by VI of S equal to what? 1 by SC by R plus SL plus 1 by SC. This can be written as 1 by S. LCM you take S square LC plus SCR plus 1. Now divide with LC. Numerator, denominator, divide with LC. Then what I will get? 1 by LC by S square plus S into R by L plus 1 by LC. So 1 by LC divided by S square plus S into R by L plus 1 by LC. Now compare with standard form. Compare with standard form. Compare with standard form. What is that? C of S by R of S equal to omega n square by S square plus 2 zeta omega ns plus omega n square. So now what I will get? Omega n equal to what? 1 by root LC. Radians per second. Zeta equal to what? Already we find all these things. R by 2 root of C by L. Next, quality factor. Actually, we don't require this quality factors. All this will come in the network theory. Quality factor. But in terms of zeta, there is a formula. Quality factor. Q equal to 1 by 2 zeta. That equal to 1 by R root of L by C is the quality factor. Resonance occurs only in RLC circuit as second order. When XL equal to XC, then resonance occurs. It is not occurs in the first order system. Be remember, I think he knows. Now draw the frequency response. Draw the frequency response for RLC circuit. So draw it. Draw the frequency response for RLC circuit. Right. The frequency at omega 0, what is the magnitude? Tell. Put omega 0, S0, this is 0, this is 0. What you are getting? Omega n square by omega n square means 1. So that means this magnitude is 1. So the frequency at which maximum magnitude occurs is called resonant frequency, omega r. That maximum magnitude, whatever is there, that is called MR. The maximum magnitude is called MR, resonant peak. The frequency at which the magnitude dropped to 1 by root 2 times of the maximum magnitude. The frequency at which, this is 1. 1 by root 2 times of the maximum magnitude. 1 by root 2 times of the maximum magnitude is called bandwidth. The frequency at which the magnitude dropped to 1 by root 2 times of the maximum magnitude at the low frequency. At the low frequency gives the bandwidth. In case you want to write in dB, you can write dB. This is 1 in dB means 20 log 1 becomes 0 dB. 1 by root 2 dB you find minus 3 dB. That's why bandwidth they used to represent in 3 dB also. 20 log of 1 by root 2 value minus 3 dB. 20 log 1 is 0. So what is the bandwidth? It is a range of frequencies at which the magnitude dropped to 1 by root 2 times or minus 3 dB from the maximum value at low frequency, not resonant frequency. Resonance not exist always. Resonance exists only when zeta less than 1 by root 2. When zeta less than 1 by root 2, then only resonance exists. Zeta greater than or equal to 1 by root 2, there is no resonant peak, there is no resonant frequency. There is no resonant peak, there is no resonant frequency. Okay? First, resonant frequency. the frequency at which maximum magnitude occurs. The frequency at which maximum magnitude occurs. Maximum magnitude occurs. The frequency at which maximum magnitude occurs. So that is omega r equal to omega n into root of 1 minus 2 zeta square. Radians per second. Omega r equal to omega n into root of 1 minus 2 zeta square, radians per second. Next, resonant peak. Be remember this formulas. Resonant peak. It is the maximum magnitude at resonant frequency. It is the maximum magnitude at resonant frequency. It is the maximum magnitude at resonant frequency. That is MR. Actually, MR standard form means K by 2 zeta root of 1 minus zeta square. K by 2 zeta root of 1 minus 2 zeta square. Default by default K1 aya. Are you observed here? K is the magnitude at omega equal to 0. K is the magnitude. Sometimes they don't give year 1. That's why K is the magnitude at omega equal to 0. At omega 0, what is the magnitude here? 1. So that means K equal to 1. That means what is the formula for MR? 1 by 2 zeta root of 1 minus zeta square. In case here gives 10, 10 by 2 zeta root of 1 minus zeta square. In case here given 10, 10 by 20, 20 by, like that you have to consider. In the numerical, sometimes they are not giving 1. That's why I put it K. Okay, K is called closed loop system gain. K is called the closed loop system gain. Or in this here K you put it, then we will get the K there. Okay. Next bandwidth. Next bandwidth. It is the range of frequencies. It is the range of frequencies. It is the range of frequencies at which it is the range of frequencies at which the magnitude dropped to drop to 1 by root 2 times of the maximum value at low frequency. At low frequency. What is the formula for bandwidth? Omega n into root of 1 minus 2 zeta square plus root of 2 minus 4 zeta square plus 4 zeta power 4 radians per second. This is the bandwidth. What is the bandwidth for first order system? Anybody? Bandwidth for first order system. One by tau. Very good. DC gain will find for only stable system. First be remember. DC gains generally will find for stable systems. We don't consider any pole at zero. We don't consider multiple poles at all. When there is no pole at origin, then DC gain, system gain, steady state gain, all are same. When there is no pole at origin, we remember. Pole at origin, then we don't calculate DC gain at all because system is not stable. Right, next. Anywhere they ask the DC gain, generally that system is stable system, we remember. Otherwise, they don't ask the DC gain. Right, next one. Bandwidth of, this is for second order system. It is for second order system. First order system bandwidth. How to find bandwidth actually? Bandwidth or the bandwidth, the magnitude equal to 1 by root 2. If you make it, you will get the answer. For example, first order system I will take. C of S by R of S equal to K by S tau plus 1. It is a first order system. S replaced by J omega. So C of J omega by R of J omega equal to K by J omega tau plus 1. Write the magnitude. K by root of omega tau whole square plus 1. At bandwidth. Even second order bandwidth also same way we got it. We have to write the magnitude for the second order system, make equal to 1 by root 2. This is the equation like minus b plus r minus root of b square minus 2ac. Based on that, we got it because of second order. First order very easy. At bandwidth, magnitude equal to 1 by root 2. 1 by root 2 means here k by root 2 because magnitude at omega 0, how much k? Magnitude at omega 0 here k, yeah. That means at the bandwidth, magnitude equal to k by root 2. Maximum value k here. Omega 0 put it k by root 2. Maximum value will get at omega 0 because these are low pass filters. Okay? And now bolo. So k by root 2 equal to k by root of omega tau whole square plus 1. K cancel, root cancel. So 2 equal to omega tau root square plus 1. Then omega equal to what? 1 by tau. So bandwidth for first order is omega equal to 1 by tau radians per second. First order bandwidth is 1 by tau. Second order bandwidth is omega and root of 1 minus 2 zeta square plus under root of 2 minus 4 zeta square plus 4 zeta power 4. But there is a simple shortcut for the second order system bandwidth. What it is means, be remember. And in case time not permits, then only it is approximated. Bandwidth for second order, bandwidth equal to omega n into 1.85. Approximately same you will get. Slight different. 1.2 zeta radians per second. 1.85 minus 1.2 zeta radians per second. This is approximate, not exact. So if time not permits, use omega n into 1.85 minus 1.2 zeta. Time permits, use this. This is the what? Bandwidth definition, bandwidth formula. Okay. Next one problem is solved. Come on. Solve one problem. Write it. The frequency response of second order system is shown in figure. The frequency response of second order system is shown in figure. Is shown in figure. Find the transfer function. Find the transfer function. Come on, draw the frequency response. Come on, do it. Come on, get the answer. Oh, 1 minute. MR formula. Here, 1 minus zeta square. Here correct only. Here I written wrong. K by 2 zeta root of 1 minus zeta square. Come on, get the answer. What is MR? Tell. MR equal to K by 2 zeta root of 1 minus zeta square. Bolo 10 by root 3 equal to MR is 10 by root 3. What is K? At omega 0, K 5 na? So 5 by 2 zeta root of 1 minus zeta square. 5 2 ja. So 2 by root 3 equal to 1 by 2 zeta root of 1 minus zeta square. Come on, get the answer. Get the zeta value. Square on both sides and simplify. Come on. Get the zeta value. Anybody solved? Anybody solved? So what is the answer? .866. You will get zeta 2 values you will get. Zeta equal to 0.5 only you will get. And other one I think 0.866 you will get. And one more thing, you be remember, resonant peak occurs only when zeta less than 1 by root 2. In case zeta greater than 1 by root 2, you will get the response like this. This is for zeta greater than or equal to 1 by root 2. So here there is no resonant peak at all. There is no resonant frequency that will become 0. Resonant peak, listen. Resonant peak and frequency exist only when zeta less than 1 by root 2. If zeta greater than or equal to 1 by root 2, then there is no resonant peak. There is no resonant peak and frequency. There is no resonant peak and resonant frequency. Resonant frequency. In this case, so MR, omega R becomes the 0. Simply 0. No need to calculate. And MR becomes 1. At omega 0, what is the magnitude? 1. At omega 0, magnitude is 1. That's why MR becomes the 1. If zeta greater than or equal to 1 by root 2, blindly we can write omega R 0, MR 1. If zeta less than 1 by root 2, then only resonant peak, resonant frequency exists. That means here you have to consider 0.5. Zeta is 0.5. Next, calculate omega n given. What is omega n given? Omega n equal to 5 root 2. That equal to what? Sorry, omega r. Omega r given 5 root 2. That equal to what? Omega n root of 1 minus 2 zeta square. Substitute zeta value. So 5 root 2 equal to omega n root of 1 minus 2 into zeta square. Zeta square means 0.25. 0.5. Then solve it. Omega n become, I think, 10. 10 radians per second. I think 10 only. 10. Now write the transfer function. Transfer function. C of s by R of s equal to k into omega n square by s square plus 2 zeta omega ns plus omega n square. So k is 5. Omega 0, k na, k 5 na, here given 5. This is k only. 5 into 100 by s square plus 10s plus 100. That's all. This is the transfer function. This is the transfer function. That's all. Next, we'll start the border plots. Border plots. Border plots. First purpose. First one is to draw the frequency response of open loop transfer function. To draw the frequency response of open loop transfer function. That is G of s, H of s. Second, to find the closed loop distance stability. To find the closed loop distance stability. Third one, to find the gain margin and phase margin. To find the gain margin, phase margin, gain crossover frequency, and phase crossover frequency. Next, to find the relative stability. To find the relative stability by using gain margin and phase margin. To find the relative stability by using gain margin and phase margin. Bolo. If the gain margin, phase margin is very, very large, what happens? If gain margin and phase margin both are very, very large, then what happens? Tell system more relative stable. System more relative stable. RS means relative stable. But the problem is slow response. But the whenever gain margin, phase margin very, very large means blindly we can say system response is slow. The race time becomes large. Race time becomes large. In case gain margin, phase margin become very small, what happens? If gain margin and phase margin is very, very small, then what happens? System is less relative stable. Less relative stable. But what is the problem? And system response is more oscillatory. System response is more oscillatory. Here both are disadvantages only. Here first one is advantage, second one is disadvantage. Whatever it is, we don't want large gain margin, we don't want small gain margin. Large gain margin means slow response, we don't want. Small gain margin means marginal stable, completely oscillatory. Gain margin, phase margin equal to 0 means what? Marginal stable. Marginal stable is more oscillation. We don't want more. Then what is the optimum value? The optimum value of the gain margin is the optimum value of gain margin is 5 dB to 10 dB. And phase margin is around 30 degrees. Phase margin is around 30 degrees. 25 to 35, like that we can take. So next, what is a border plot? What is a border plot? What is a border plot? Border plot is a frequency domain analysis. It is a frequency domain analysis. Domain analysis. It is a frequency domain analysis. It consists the magnitude and phase plot. It consists the magnitude and phase plot. What is the magnitude plot? Magnitude versus frequency. Omega. This is magnitude in dB considered here. Frequency. For example, it is 0.1. What is the 1 dB frequency? 1 decade frequency. What is the meaning of decade? 1 decade frequency. 1 decade means 10 times change in frequency. 10 times change in frequency. 0.1 to 1 is 1 decade. For example, if omega 2 is a final frequency, omega 1 is a initial frequency related by 10 times in the decade. Whereas in octave is omega 2 is a final frequency, omega 1 initial frequency related by 2 times in the octave. Don't take 8 times, 2 times only. In octave it is 2 times. Why? Because for double the frequency of voice signal, change in angle is 8 degrees. That's why they put a word octave. Frequency voice signal is double. Change in angle, phase shift is 8 degrees. That's why they put octave. Whatever it is, be remember. Here we don't require this. What is required means conversion is required. What is that conversion? 20 dB for decade must be equal to 6 dB for octave. In any question they give in octave, convert into decade. 6 dB for octave equal to 20 dB for decade. Be remember, that is enough. Next phase plot. This is omega. This is phase. This is 0 degrees. This is the phase plot. So phase in degrees. That's all. Next, the drawing procedure to draw the border plot and the remaining things better we'll discuss tomorrow. Up to this, be remember. At least border plot definition remember. Conversion remember. Okay. I'll close here. If you have any doubt, you can ask. Sri Charan. Sri Charan.
Hello, sir. 18F, sir.
10.
18, sir. 18. Sir, here less than 1 by root 2 means we can take 0.6 also, no, sir. Zeta value.
What is zeta values you got?
Actually, 0.866, no, sir.
That is invalid, na? Zeta is greater than 0.707, na? No resonant peak exists.
Yes, sir. We can take 0.6 also, no, sir.
How can you take 0.6? Whatever the answers you are getting, in that one you have to select, na?
It is less than 0.7, no, sir.
Again you are telling same.
Okay.
We got 2 values in the 2 which is valid.
Okay, sir. Sorry. Okay. Got it, sir. Got it.
Okay. Amulya.
Good evening, sir.
Good evening, Chepamma.
Sir, I have a doubt. How can we relate root locus with gain margin, sir? Root
You
locus
can
plot
find
with
gain margin is nothing but K marginal value. It will come in the next coming classes.
Okay.
Separate gain margin, phase margin calculations are there. There I'll discuss.
Okay, sir.
Gain margin is nothing but K marginal by K desired value or simply K marginal.
Okay.
K desired gives 1. If not mentioned any K desired value, simply gain margin is called K marginal value.
Okay. There was a question, sir, like if root locus doesn't intersect the imaginary axis, then what would be?
Gain margin infinity.
Oh.
Because not intersecting imaginary axis means it is absolutely stable system. For all the values of K, it is stable. Whenever root locus does not intersect the imaginary axis, blindly we can write gain margin infinity.
Then what will be K desired, sir?
K desired, it will come. They will give how many times gain is increased? That is called K desired.
Okay. That
Okay.
means
Sometimes gain is doubled. They will ask gain margin. And a K marginal by 2 times of K. They'll mention the K value.
in this question, how can we know, sir, gain margin infinity?
Which question?
I mean, when root locate doesn't intersect imaginary axis.
What is the range of K for stability?
0 to infinity.
That means the gain margin how much? Gain margin finite
One.
means range of K also finite.
Okay.
If you are telling K range of K 0 to 100 means gain margin is what? 20 log 100 how much? 40.
They didn't mention that.
Both
sir,
are
in the-
same. Gain margin in dB. K is in linear, that's all.
Sir, if they don't give a range of K, then
Default 0 to infinity na.
okay, sir. Okay. Yes, sir.
Okay. Any more doubts? I'm closing. Any doubts you can ask? Tomorrow at 6 to 9, 6 o'clock tomorrow. Today because of some class for this college goers. Last class it is extended, that's a half an hour delay. Tomorrow 6 to 9. Karthik.
Sir, for third order system or any higher order system, for finding time constant, can we add
Third order
the
system
time?
means what are the poles tell? Third order is a combination of first order and second order.
Okay.
Or it may be 3 first order. Any
Okay.
higher order system, we are having 2 variety of poles only. One is real, one is complex. You
Yes,
tell
sir.
third variety of pole?
Okay, not possible.
Not possible. That's all. Time constant of either first order or second order only. That's all. Infinite
okay,
order
sir.
system is defined in terms of first order and second order only.
Okay, sir.
Okay,
Sir,
na?
for second, yes, sir. Sir,
Second
for second
order
order
default is 1 by zeta omega n, because second order system you are designing means generally 99 point by default underdamped only they design, that's all.
Okay. Sir, for other systems, like can we take inverse Laplace and e power minus t by tau form, write it
We
in
can
e
take
power
it if
minus?
you are able to find inverse y, but wasting the time. Now pole location you find directly you can take. If you in case they give c of t, compare with e power minus t by tau.
Okay, okay, sir. Sir, we can't. Can we add time constants?
Time constant?
Can we add time constant if we cannot neglect insignificant poles?
No, never add the time constants.
Okay, fine, sir.
Not added. Arnachalam.
Sir, I just got an internet disconnection. So, like, what is that gain margin, phase margin alone? So, I got
It will come, man. Not at frequency domain. Today only started, na?
No, sir. Like, you just said about that gain margin as increased.
Everything will come. Wait, another 2-3 days.
Oh, okay, sir. Like,
any more? Right.